Every single day, we create an absolutely staggering amount of data. Every photo you post, every time you add something to an online cart, every message you send, all of that has to be stored somewhere, organized, and ready to be found in a split second. So let's pull back the curtain and explore the invisible world that makes all of that possible. So, where does it all actually go? I mean, it can't just be a giant, messy pile of files on some huge hard drive, right? That would be total chaos. And asking that question leads us to one of the most fundamental yet completely hidden technologies of our modern lives. Okay, so on one hand, you've got your basic file system. You can think of this like a messy digital attic, where files are just kind of tossed in wherever. Trying to find anything specific in there? Yeah, good luck. But on the other hand, you have what's called a database management system, or a DBMS. Now this is like having a perfectly organized library with a genius librarian who knows exactly where every single piece of information is. And that is precisely what a DBMS is. It's not just a box you dump data into, it's a super smart, active system designed to manage everything, to store it, to keep it secure, and to let you get to it quickly and efficiently. It's that brilliant librarian for all of our digital stuff. So why do we even need this digital librarian? Why not just stick with simple folders? Well, as it turns out, the advantages are just huge. What's really cool is how all of these benefits are connected. For instance, when you get rid of redundant data, you're not just saving disk space, you're also making sure your data is consistent. Think about it. If a customer's address is only stored in one single place, you only have to update it once, and that prevents all kinds of mistakes. And that same central control is what lets a DBMS lock things down, managing exactly who gets to see or change what information. And you might be thinking this is all super technical, behind-the-scenes stuff, but the truth is you are using databases constantly, every single day. Anytime you check your bank balance, book a flight, or buy literally anything online, you're talking directly to a database. Your school records, your phone company keeping track of your data usage. It is all being powered by these systems working quietly in the background. So here's the bottom line. Databases aren't just some small part of our digital world. They are the actual engines that make the whole thing run. Without them, our modern lives would pretty much grind to a halt. Okay, so we get it. They're incredibly important. But how do they really work? Let's take a quick peek under the hood and see what's going on. Most modern systems are built using something called a three-tier architecture. So at the very top, you've got the client. That's you on your phone or your laptop. Then in the middle, there's the server application, which handles all the complex logic. And way down at the bottom is the database system itself, where the data actually lives. Separating them like this makes the whole system more secure, easier to scale, and a whole lot easier to manage. And before you can even start building a database, you need a blueprint. That's what you're looking at here, an entity relationship diagram. It's the master plan. It maps out all the key pieces of information, the entities like student and college, and it defines exactly how they connect to each other. Getting this blueprint right from the very beginning is absolutely critical to keeping everything organized and running efficiently down the line. Now, this all works beautifully for, say, a college or a local bank. But what happens when you're operating at the scale of a global social network or a massive e-commerce company? Well, the challenge changes completely. All right, so for these huge, modern cloud databases, the goals sound simple, but they are incredibly hard to actually pull off. They have to be lightning fast, they need to scale almost infinitely, and they have to be totally, completely reliable. Because when millions of people are depending on you every second, the stakes are just unbelievably high. So how in the world do you actually do that? With millions of users hitting your system all at once, how do you guarantee that kind of perfect performance? Well, the answer is hidden in a layer of complexity that almost nobody ever gets to see. Hundreds. You see, modern databases have literally hundreds of different configuration settings. You can think of them like tuning knobs on a giant, complex machine. They control everything from how memory is used to how queries are processed. And to get that perfect performance, you have to get every single one of those knobs set just right. This is what people in the field call the tuning nightmare. It's a nightmare because when you change one knob, it can have a totally unpredictable ripple effect on 10 others. Plus, the workload is always changing. What worked perfectly yesterday might be terrible today. A single wrong setting can bring the whole system's performance to a crawl. It's a massive, constant headache. So how do we solve this nightmare?
how do we possibly build systems that can handle all this complexity and scale? Well, the answer is pretty simple. You have to make them smarter, and you have to make them stronger.
To beat this tuning problem, two really big innovations are leading the charge. First, we're making these systems smarter. We're actually using AI and machine learning to create self-tuning databases. They watch their own workload and automatically adjust those hundreds of knobs to find the perfect settings, all without a human needing to lift a finger. And second, we're making them stronger by building them as distributed systems, spreading all the work across lots of machines instead of relying on one single giant server that could fail. And that's exactly what a distributed database is all about. Instead of putting all your data in one basket, you spread it out across an entire fleet of servers that all work together like one giant, powerful system. The power you get from this is just immense. If you need more capacity, you don't build a bigger, more expensive server, you just add more cheap ones. That's horizontal scaling. It's way more flexible. And by copying your data across multiple machines, you make sure that if one of them fails, the system doesn't even blink. Another one just takes over instantly, giving you incredible reliability.
And hey, this isn't some science fiction idea. This architecture is what makes today's most demanding apps even possible. I'm talking about the massive data sets needed to train AI models and the split-second transactions of global finance. They simply could not exist without the power of distributed databases.
So think about it. What started as just a simple digital librarian has now evolved into a globe-spanning, self-tuning brain. This technology gave us the foundation for the cloud, for social media, for the internet as we know it. The only real question left is, what impossible things will it allow us to build next?